Today we are going to study structural isomerism. But first of all, let us define isomerism. The existence of different compounds having the same molecular formula but different structures is called isomerism. There are two main classes of isomerism. Number 1, structural isomerism. Number 2, stereoisomerism. Today we will discuss structural isomerism and its types with examples. Students, this topic becomes very easy if you understand structure building. So today we will not memorize. We will build structures step by step. Suppose I give the molecular formula C4H10. Now first understand what this means. C4 means 4 carbon atoms. H10 means 10 hydrogen atoms. Now students, our job is to arrange these atoms. Different arrangements can produce different compounds. This phenomenon is called structural isomerism. Now we will discuss different types of structural isomerism. Number 1, chain isomerism. Students, first we will build the first possible structure. Always start with the longest carbon chain. Take again C4H10. Arrange all 4 carbons in a straight line. C-C-C-C. Now remember, carbon always forms 4 bonds. Currently, the first carbon has 1 bond. The second carbon has 2 bonds. The third carbon has 2 bonds. The fourth carbon has 1 bond. Now complete the remaining valencies using hydrogen atom. Now the final structure becomes CH3 CH 2 CH3. This compound is called normal butane. Now students, we will build the second arrangement using the same molecular formula. Again start with 4 carbons. But this time do not place all carbons in a straight chain. Arrange 3 carbons in a line. C-C-C. Now attach the fourth carbon to the middle carbon. Now complete the valencies carefully. The first carbon becomes CH3. The middle carbon already has 3 carbon bonds, so it needs only 1 hydrogen atom. Therefore it becomes CH. The upper carbon becomes CH3. The last carbon also becomes CH3. This compound is called methylpropane. Now compare carefully, students. Both compounds have the same molecular formula, C4H10. But their carbon arrangements are different. One compound has a straight chain. The other compound has a branched chain. Therefore, they are called chain isomers. This type of isomerism is called chain isomerism. Number 2, position isomerism. Now students, take the formula C3H7OH. First draw the 3 carbon chain C-C-C. Now attach the OH group to the first carbon. The structure becomes CH3-CH2-CH2OH. This compound is called propan-1-ol. Now students, keep the same carbon chain. Do not change the carbon arrangement. Only move the OH group. Attach OH to the middle carbon. Now the structure becomes CH3-CHOH-CH3. This compound is called propan-2-ol. Now observe carefully, students. The carbon chain is the same. The OH group is also the same. Only the position changed. Therefore, this type is called position isomerism. Number 3, functional group isomerism. Students, this type is extremely important. Here the molecular formula remains the same, but the functional group changes completely. Take the formula C2H6O. First arrange carbons together, C-C-OH. Now complete the valencies. The final structure becomes CH3-CH2OH. This compound is ethanol. Students, observe carefully. Here, oxygen is attached to hydrogen. So the functional group is OH, which is the alcohol functional group. Now students, we will rearrange the same atoms differently. Place oxygen between 2 carbons. Now complete the valencies. The final structure becomes CH3-O-CH3. This compound is dimethyl ether. Now observe carefully, students. Both compounds have the same molecular formula, but the connectivity of oxygen changed completely. In alcohol, oxygen is attached to hydrogen. In ether, oxygen is present between 2 carbon atoms. Therefore, the functional group changed. This type is called functional group isomerism. Number 4. Metamerism. Students, take the molecular formula C4H10O. First build an ether. CH3-O-CH2CH2CH3. Students observe carefully. On the left side of oxygen there is a 1-carbon group. On the right side there is a 3-carbon group. This compound is called methoxypropane. Second structure. Now students, keep the same ether linkage. Again oxygen stays in the middle. But now distribute the carbons differently. Attach 2 carbons on the left side and 2 carbons on the right side. The structure becomes CH3CH2-O-CH2CH3. This compound is called ethoxyethane. Now compare carefully, students. The functional group is the same. The molecular formula is also the same. But the alkyl groups around oxygen changed. In the first structure, 1 carbon is on the left side and 3 carbons are on the right side. In the second structure, 2 carbons are on the left side and 2 carbons are on the right side. Therefore, this type is called metamerism. Important trick. Students, remember, if the functional group remains the same, but the carbon groups around the heteroatom change, then it is metamerism. Number 5. Ring chain isomerism. Students, in this type, one compound forms an open chain structure while the other forms a cyclic ring structure. Take the molecular formula C3H6. First structure. Arrange 3 carbons in a chain, C-C-C. Now students, the formula has only 6 hydrogens. This means one double bond must be present. So place a double bond. The structure becomes CH2 double bond CH-CH3. This compound is propene. It is an open chain alkene. Second structure. Now students, using the same 3 carbons, make a ring. Join the first and third carbon together. This forms a triangular ring called cyclopropane. All bonds are single bonds. Now compare carefully, students. Both compounds have the same molecular formula, C3H6, but one structure is open chain and the other is cyclic ring. Therefore, this type is called ring chain isomerism. Number 6. Tautomerism. Students, this is one of the most important advanced concepts in organic chemistry. Unlike ordinary isomerism, here compounds continuously convert into each other. This usually happens through hydrogen shifting and double bond shifting. The most important example is keto-enol tautomerism. First structure. Keto form. Take the structure CH3-CO-CH3. Students observe carefully. The middle carbon contains C double bond O. This is called the carbonyl group. Therefore, this is the keto form. Conversion step. Now students, a hydrogen atom from the adjacent carbon shifts toward oxygen. At the same time, the double bond also shifts. This is extremely important. Hydrogen movement and pi bond movement occur together. Second structure. Enol form. Now the structure. Students observe carefully. Now the compound contains a double bond and an OH group together. This is called the enol form. N means alkene. Ol means alcohol. So students, today we discussed chain isomerism, position isomerism, functional group isomerism, metamerism, ring chain isomerism, and tautomerism. Practice structure building again and again. Once your structure building becomes strong, structural isomerism will become very easy. Thank you, students.